Hi, I'm Matt, and in this video we are going to go over how to balance chemical equations. Before we start balancing equations, it's important to go over the idea of the law of conservation of mass, because that's why we have to balance in the first place. It says that matter cannot be created or destroyed, only change form. So in a reaction, all matter is conserved. The amount of each element in the reactants must be equal to the amount of each element in the products, and we balance to make sure that they are equal. So for example, if there were 4 hydrogens and 2 oxygens on the reactant side, there must also be 4 hydrogens and 2 oxygens on the product side, or the other side of the equation. We could help visualize this using this image here, where you see we have 4 red circles representing hydrogen on both sides, and we have 2 blue circles representing oxygen on each side. This is balanced because the law of conservation of mass is not violated. Now with that out of the way, now how do we balance an equation? So the first thing is that we can only change the coefficients and not the formula. H2O can be doubled and we can have 2 waters or 2 H2O, but we can't change it to make H3O because that is a different substance. We're going to balance atoms that are by themselves last, and when we have polyatomic ions such as hydrogen carbonate that do not break apart, we could balance them as a unit rather than balancing them separately. So the hydrogen doesn't have to be balanced separate from the carbon in this example. And then the last step is that we have to simplify the coefficients to smallest whole number ratio. So if we had 4H2 plus 2O2 goes to 4H2O, we could divide all those coefficients by 2 and get 2H2 plus O2 goes to 2H2O. The last thing to mention, I didn't write it here, is that we could omit a 1 because if there's no number, it's implied to be a 1. So now let's try some examples. Okay, so our first example is N2 plus H2 goes to NH3. Those lines in front of each of the substances are where we're going to put the coefficients. So the first thing we're going to do is that we're going to write how many of each element we have on each side. So for the reactants, we have 2 nitrogens, and for the hydrogens, we also have 2. While on the products, we only have 1 nitrogen, but have 3 hydrogens. So I'm going to start by balancing the nitrogens just because they're the easier of the two to balance. So to do that, we could put a 2 here because that will give us 2 times 1, which will give us 2 nitrogens. But when we change that, we also change the amount of hydrogens because 2 times 3 gives us 6. So now we have to balance our hydrogens. Since we have 6 hydrogens on the right and only 2 on the left, that's 3 times more on the right. So we could put a 3 in front of the H2, and 3 times 2 gives us 6. Now the final check to make sure we did it right. 2 nitrogens, 2 nitrogens. 6 hydrogens, 6 hydrogens. Since we have the same of all species on both sides, we know that our balancing is correct. So the next question we're going to try is Al plus O2 creates Al2O3. So just like the last question, we're going to list the amount of each element. On the reactant side, we have 1 aluminum and we have 2 oxygens. And then on the product side, we have 2 aluminums and 3 oxygens. Now, we could put a 2 here and balance the aluminums, but we're not going to because that will most likely change. So, like I said earlier, we're going to leave the elements by themselves to the end. We're going to deal with the oxygens first. So, there's no whole number we can multiply by 2 to get 3. So what we're going to do is we're going to crisscross them. We're going to take this subscript and we're going to put it here. And then we're going to take this subscript and we're going to put it here. So we have 2 Al2O3 and then we have 3 O2. 3 times 2 gives us 6 oxygens on the left. and then 2 times 2 gives us 4 aluminums, and 2 times 3 gives us 6 oxygens on the right. You now probably see why we didn't balance the aluminums first, because then we would have to change it again. The last step to balance this is to make this 4 aluminums, because then we have 4 aluminums on both sides and 6 oxygens on both sides, so our equation is correctly balanced. Our third example of CO plus O2 creates CO2 is a little trickier because we have oxygen in 2 places in our reactants, so we're not going to be able to do crisscrossing like we did in the last one. But nevertheless, we're still going to start by listing the amount of each element. So we have 1 carbon and 3 oxygens. While on the right, we also have 1 carbon, but only 2 oxygens. So to balance this, we're only going to be able to put a coefficient here, which will be multiplied by 2. So we could only ever have an even amount of oxygens on the right. So this 3 here won't work, because we'll also need an even amount of oxygens on the reactant side. So to make this an even number, we could put a 2 here, which makes 2 carbons and 4 oxygens. Now that threw off our carbons. So to make 2 carbons on this side, we're going to have to put a 2 here as well, which will give us 2 carbons, because 2 times 1, and then we'll do 2 times 2 to get 4 oxygens. Now we have 2 carbons on both sides and 4 oxygens on both sides, so our equation is correctly balanced. We could put a 1 here, but we could also omit it, like we usually do when we write equations. For our fourth example, we're going to start using polyatomic ions, such as NO3. So, since there's NO3 on the left and the right, and it doesn't break apart, we could balance that whole NO3 as a unit on both sides. Now, that 2 outside of the parentheses means we have 2 of the whole polyatomic ion. And then we have 1 Pb, or lead, 1 Na, and 1 Cl. While on the right, we also have 1 Na and 1 Pb, but we have 2 chlorines, and we have 1 NO3. So I'm going to start by balancing the NO3s, just because that's at the top of my list. It doesn't really matter. So to do that, I'm going to put a 2 here, which will give us 2 NO3s, and will give us 2 sodiums. Now, that just threw off the balance with sodium, because we have 1 here and 2 here. So to fix that, I'm going to put a 2 in front of the Na on the reactant side as well, which will give me 2 sodiums, but then 2 chlorines as well. And that actually finishes up the balancing, because we have 2 sodiums and 2 sodiums, 2 chlorines and 2 chlorines, 2 NO3s, 2 NO3s, and 1 Pb on both sides. We're going to leave these blank, or if you really wanted to, you could put a 1. But like I keep saying, we usually omit those in chemistry. Now we're going to try one more example where the polyatomic ion is going to break up. For our last example, we're going to do a problem where the polyatomic ion does break up. So here we have ClO3 on the left, but not on the right. The way we start is no different. We're going to write the amount of each element from each side. So on the left are the reactants. We have 1 magnesium. And now, remember that 2 gets distributed to everything in the parentheses. So we have 2 chlorines, and then we have 6 oxygens, because 2 times 3. On the right, we also have 1 magnesium. We also have 2 chlorines, but we only have 2 oxygens. Now, this one actually isn't too bad, because the only thing we have to do to get oxygen to have 6 on the product side is put a 3 here, because 3 times 2 makes 6. And that doesn't change anything else, so our equation is already balanced, besides that 3. Remember, we're not going to put the 1's there because those are assumed. So, we get that there's 1 Mg on both sides, 2 Cl's on both sides, and 6 oxygens on both sides, so it passes our check. Now that we've worked together to balance 5 different equations, here are 5 more equations that I encourage you to try balancing on your own. At this time, I would suggest you pause the video and work on them. The answers to each of these will be provided for you on the next slide. The solutions are as follows. Question 1, when balanced, is 2KCl creates 2K plus Cl2. Question 2 solution is 2Al plus 3CuSO4 creates 3Cu plus Al2SO43. For question 3, you should have gotten Fe2O3 plus 3CO creates 2Fe plus 3CO2. For question 4, the solution was 2H2O plus 2Na goes to 2NaOH plus H2. And finally, for question 5, you should have gotten BaClO3 2 goes to BaCl2 plus 3O2. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.